So within the software development industry, we've noticed recently and for the last decade or so that the industry is becoming huge. The software code base has grown phenomenally, and developers are now creating code for enterprise apps, websites, and other softwares. Welcome to the world of DevOps. My name is Syed. I'll be the instructor for this course. In this DevOps Fundamentals course, I'm going to cover step by step all the phases of software development. And then I'll also highlight the important area of DevOps, which is an upcoming, ever-growing, exponentially growing field. How does DevOps fit into the picture of software app development? With reference to special enterprise apps. Let me tell you about the structure of this course. We'll start off with the very basics of understanding the software development lifecycle, which is gathering customer requirements, getting to the design phase, telling the developers to actually develop the code and the application. And then, of course, testing our code and monitoring as well. So once we cover the entire software development lifecycle, I'll jump in and explain what waterfall approach is and the agile development approach. And we'll take a look at the differences between these two approaches. Then we'll dive into the development and operations teams and how DevOps combines those teams together. Subsequently, I'll highlight an important element of DevOps, which is using the tools, because you need tools to combine all these environments, and each of these tools, they work at different phases of the development lifecycle. So tools such as Jenkins, Kubernetes, Docker, you may have heard other tools like Relic, for example. So I'm going to highlight and also demonstrate so that you get a better understanding of how these tools look like in action. So the goal of this course is to give you the basics, fundamentals of DevOps, what it is, the history, value, and all of the rest of the things that I just mentioned. I value your feedback. It's very important to me. The positive feedback that you provide makes my courses even better and better over time. And of course, I encourage, if you do not understand something or if you have additional questions, please post them into the discussion area. That's the best learning experience for all students, and for myself, I'll be happy to answer those for you. So what are you waiting for? Click on the Enroll Now button and I will see you in class. Welcome to this course on DevOps Fundamentals Gain Solid Understanding. My name is Syed Raza. I will be the instructor for this course. Before I begin the actual course agenda, just briefly about myself. I've been in the training industry for a little over 20 years, and as a certified Microsoft System Engineer, DevOps Specialist, Enterprise Project Manager, and other roles as well. My transcript at this point is kind of heavy duty with all these certifications and experience as well. So currently I'm working as a senior project manager with an enterprise IT firm in the United States, and I manage global projects. I've seen that due to DevOps, my colleagues, my students, and thousands of students have approached me so far, wanted to understand what DevOps is all about. So I put together this course, fundamental course, just so that you can gain solid understanding of the entire process. What does it entail? So I'm going to start off, for example, with just the basics of software development lifecycle. So we understand as programmers, developers, or IT professionals or architects, we understand how the software development lifecycle works. And pretty much already, you may already know this, but this will just be a refresher. So we'll talk about the waterfall approach, the agile development, and then of course dive into the DevOps. How does it integrate the operations and the development? So you have dev teams working on developing an enterprise app, and then of course you have the operations team. What about the QA? What happens to the quality assurance or the QA testers like they used to do in monolithic applications, right? So I'm going to talk about that as well and the role of QA briefly. How does that fit in and where do these people go? So after that, I'm going to talk about the integration, the continuous integration, the continuous delivery of the entire pipeline, right? So once you start the development of a certain app, how does it actually move towards the end, which is the customer delivery, right? And everything happens in real time. So I'll talk about the entire DevOps lifecycle. I will also give certain examples, maybe a demo lesson on Kubernetes. That's from one of my earlier classes on DevOps engineer class that I put together. I talk about Docker, Kubernetes in that class. So if you're looking into hands-on, in-depth course, then of course you want to take that course. But here in this particular course, I'm going to stick to the fundamentals, just so that you have a solid understanding for this entire DevOps course. If you have any questions, feel free to post in the discussion area. I'll be happy to help. And I'm super excited. This is one of my best courses so far that I've put out together. And then I'll like to show you some of the reviews that one of my students gave. And this is one of the best reviews I've ever had, and I'm super excited so far. So with this, let's jump right in and let's move to the next course. But before we do, let's take a look at this review and then we'll move on. I welcome you again, and thanks for joining the course. Welcome to this lesson on Software Development Lifecycle, also known as SDLC. So in this lesson, I'm going to just give you the fundamentals and visual fundamentals. So there's no text. All I'm going to do is just walk you through the basic software development lifecycle, the waterfall model, the agile methodology, and then we'll end up with what DevOps is and how does it work currently. So what is the SDLC? The basic software development lifecycle, as we know, is we start off with the requirement analysis, we design the software, we develop the software. Once it's developed, we get into testing of the software, bug fixing, and so on. And then finally, the maintenance of the software, such as newer versions and so on, based on the client feedback. So this is the typical methodology which is currently being used in the industry overall, or has been for the last several decades. The waterfall model. While developing software, we can choose this model to develop our new software or new app. So once again, notice that it entails similar requirements as the basic software development lifecycle, which is starting from the top, requirement analysis, to design, down to implementation, testing, and maintenance. So using this approach simply means that you're doing everything step by step, right? So you finish the requirement section, then you get into the design. Once the design is completed of the software, then you get into implementation, testing, and maintenance. So last several decades, we've been using this model or approach. Next, I'm going to talk about the agile methodology, right? As time progresses, as we learn more, educate ourselves, understand the requirements and the technology, we get into the agile methodology. So this methodology is, again, it uses the same model, but in this instance, notice instead of a waterfall approach, this is more of a circular approach. In other words, we start off by defining the requirements of the software that we want to build. Then we get into the user interface design, or also known as the UI design. Once that's laid out, then the development of the actual software or app begins. Once the development is completed, we get into the QA phase, which is known as the quality assurance or QA testing. Then we get into the UAT phase, which is the user acceptance testing. And this is at the client end, typically. We also receive the client feedback towards the end before releasing. And if the client says, yes, it works fine, everything looks great, we release it. Otherwise, we go back to our defining requirements, UI design. So notice this is more of a circular approach. So this is the fundamental agile methodology that is typically being used. You will also see that there are several other models that incorporate additional details. But in this course, I just want to highlight the fundamental differences between the waterfall approach and the agile methodology. So here, once again, the basic difference. With the waterfall process, this project has got so big, I'm not sure I'll be able to deliver it. On the other hand, the agile process says it's so much better delivering this project in bite-sized sections. So instead of creating the entire software, handing it over to the customer, and just finding out that the customer is not happy and there's so many things, and you're taking the entire piece of rock back into your development room and then trying to find the bugs, right? A much more difficult process. Think of this especially in terms of large software, enterprise-wide software. Agile breaks these processes down and more of a circular approach. All right, let's talk about development and operations, right? So we talk about the waterfall and agile approaches. Next, let's get into development. What goes into development of the software and what goes in the operations? So the development of the software entails primarily version control and continuous integration. So you have shared code, for example. You're tracking changes, you're supervising, you're auditing your code, and that all goes into the version control of the app development. Next, we also need to take into consideration the backend, right, or the DB, the database of the development, which is essentially the continuous integration area of software development. This is where you can do automatic builds of your software, error notifications, integration tests, code validation, and so on. Once that section is done of development, then we get into the operations, which once again is the release management area, which contains testing, review, staging, deployment, and of course, value delivery to the client. It also entails a fourth aspect, which is monitoring, high availability, and data locality. So this is where you can monitor your application. You can do performance analytics, make sure the app is available as a high availability option. You can monitor the app and so on. Two distinct areas of development and operations. And this leads us to the actual DevOps. Perfect. So the DevOps lifecycle, right? So once again, notice the circular approach. Think of this as agile methodology that we looked at earlier. Same concept, but in this instance, what DevOps does, it sort of like functions in the middle and has its hands in all of these aspects or the phases of the software development cycle. All right. So just the basic concept of DevOps, that it spans across the entire delivery pipeline. So you push code, you can fetch changes, you can run unit tests, build artifacts, store artifacts, provision environment, deploy your build, you can run load and functional tests, and then of course from dev you can send it to QA, to staging, and finally to the production area. So within the DevOps lifecycle, the important thing to understand and memorize is the fact that DevOps is touching bases on each of these life cycles. But of course the question arises, how does DevOps handles everything, right? So we'll take a look at DevOps tools that we can use while going through the entire software development life cycle. Before I talk about tools, just want to highlight
the 7 steps or phases of DevOps and the continuous delivery lifecycle. This continuous delivery is important, and we'll take a look at it in subsequent lessons, but just briefly, we would like to make sure that our development is continuous, so it's not stopping, whether it's changes to the software, whether it's bug fixing, and so on. So as a first step, we have our business need or use cases. Then we get into the software development team. And some of the tools that are used are Eclipse, for example. That's an IDE, Integrated Development Environment. I use that all the time. It's a very nice tool. Or you can use Visual Studio for development. Then we have the software check-in. We can use Git, and I'll show you what Git is in subsequent lessons. Then we get into the continuous delivery mechanism or automated software builds. And the most popular DevOps tool is Jenkins. Next is the automated test scripts. And of course, Jenkins also provides this ability, but you can use other tools like Bamboo or Visual Studio. And for automated deployment, you can use Puppet or Chef. And then for monitoring and operations, you can use the Microsoft System Center or other tools that are available. I'll demonstrate most of these later on, such as Docker, Kubernetes, and so on. But just to give you an idea of the DevOps continuous delivery cycle. So as promised, here are the DevOps tools that we can use. So from the initiation phase, which is the first part, where the customer inputs are allowed, the tools that are used are ServiceNow platform, for example, or Salesforce. Then we get into the app development section, which contains plan, code, or build. So each of these phases has its own set of tools. For example, under plan, you can use Jira, Rally, ALM Studio, and others. For code, you can use Eclipse, Visual Studio, Git, and so on. Under build, you can use Jenkins, MS Build. For test and acceptance phase or section, within the test QA phase, you can use HP, Selenium, TestLink, and so on. And once again, you can take a look at each one of these tools. The Docker, for example, and the AWS or Google Cloud Platform would fall under the stage phase within the test and acceptance section. Similarly, moving forward, you can get to release and then eventually into the production section. You can deploy, provision, configure, and monitor. And there are various tools like Chef, Puppet. You can use SAP. New Relic is pretty popular. We use VMware to create clusters and so on. So the idea here is just so that you understand that there are several tools out there in the market that you can pick and choose based on your own requirement. So one of my other courses, the entire DevOps course with Java and Kubernetes, I walk through the entire DevOps lifecycle hands-on, right? So we deploy actual software. But here in this course, just to give you the basic fundamentals of what DevOps does to the entire software development lifecycle. So take a look at some of these concepts. Visually is nice to know and kind of see and memorize. So you understand the waterfall, you understand agile, and then of course the DevOps. So the aim of DevOps is continuous delivery so that it's always constantly moving, right? So your development is, your software app is constantly being created, fixed, and monitored. So I hope this helps. With this, let's move to the new lesson.
Welcome back. Super excited. Moving on to the concept of what DevOps really is. There are several definitions, but how do we actually define DevOps itself? So what really is DevOps? Companies from IBM and Google and large companies, they all have DevOps practices, but there's not a single definition that everyone agrees on. So DevOps can be defined as two ideas. First is the practice of operations and development. They participate together within the entire software development lifecycle, right? From the design to production. So DevOps replaces the traditional model where you have the team writes the code, tests it, deploys it, another team for testing it. Second, DevOps is also characterized by operations staff by using tools and techniques and developers for their systems. So in DevOps, systems engineer works just like developer. So nothing really is new, but the processes are efficient, right? So think about the agile learning, right? Project management fundamentals. So if you've taken one of my earlier courses on project management, or if you are comfortable and aware of the project management concepts such as Lean Six Sigma, for instance, or Agile, Scrum, that really fits into the DevOps arena very well. So if you're comfortable with those concepts, DevOps is much easier for you to work with. So this is just a high-level overview of what DevOps is. But I'm going to talk more about this as I move forward within this course. So typically, DevOps can be divided into 4 or maybe 5 levels: values, principles, methods, practices, and then tools. So I'm going to talk, of course, more about these later on in subsequent lectures. But first, let's really get to the big question. Why do you care? What's in it for me, right? How does DevOps benefit me? What is, DevOps can actually do for me? And more importantly, why would you want to practice it, right? Instead of using the traditional software development or app development methodology, why would you want to dive into DevOps? Well, the first reason is that it's been shown to be very effective in improving both IT and gaining operational efficiency and business outcomes. So, for example, a few years ago, there was a research by Puppet Labs, right? And that survey showed that teams using DevOps practices deployed changes 30 times more frequently with 200 or 250 times shorter lead times. And that resulted in, greater quality product. And of course, with fewer defects during their software development. So the idea is that DevOps is here to stay, right? And it helps. Because enterprise companies are certainly using this because of one main reason, because the shorter development lifecycle. Almost like real-time delivery of software from design to your customer. And these benefits are huge, right? Think about it. So the advantages, no doubt, are ample for you to dive into DevOps. And the second important reason is that, it makes your software development more streamlined, right? So, of course, I'm going to talk about QA later on as well. But yes, you can effectively do the continuous improvement or continuous delivery of your entire pipeline. So the DevOps approach reduces unplanned, activities and reduces stress on the job as well. So DevOps is a combination of development and operations. Really, that does not mean that all the rest of the teams can go home, right? Dev is traditionally understood to mean that everyone is usually, developing, right? From developers to front-end designers to QA. And ops is generally understood as, or traditionally as, system side, right? Maybe the network admins or Linux admins or database administrators. So it's really the collaboration of all team members collaborating and developing the software. So also when we talk about IT organizations, we talk about what product development and engineering. Some specific techniques will work better than others, and there are several tools you can use as well. So let me now tell you what DevOps is not, right? So it's not a new name for your QA team, dev team, your system admin team. It's really the same team members, just the methodology and the processes are more now efficient, right? I know, for example, in my experience as a project manager, when I first, dived into the DevOps field, I had a lot of background and skill set in project management. Of course, as a technical person, as a certified individual, all of these things came naturally to me because of all that project management experience getting into software development, managing those projects. So I was able to integrate both dev teams and the operations team, bring them onto one page, run through the entire development cycle, right? We use GitLab, for example, and I'm going to talk about several other tools later on as well. So the outcome was, of course, very productive and beneficial to the organization. So I hope this helps. Kind of gives you an idea of what DevOps is all about. Really the definition, right? It's not the standard definition. Of course, the core concept is that you are now making your software development more efficient. If you have any questions, post them in the discussion area. I'll be glad to help with this. Let's move to the next lesson. Welcome back. Super excited moving forward. In this lesson, I'm going to talk about the cultural shift to DevOps. Okay, so not so much as a technological shift, but what happens is that the underlying culture needs to be addressed carefully. So I'm going to talk about the CAMS model in this lesson. So this CAMS model was actually created by a person named Willis, right? And it stands for culture, automation, measurement, and sharing, right? That's the CAMS model. So CAMS have become a set of values used by many DevOps practitioners even today. So if you're into the DevOps field, you will hear this model fairly often, especially if you're attending conferences or events. This may come across to you. So Patrick Dubois was the father of DevOps, right? So we call him, right? And the reason why is because he focused more on the cultural aspects or the cultural shift as opposed to just automating your processes. Because really think about it. The idea of DevOps is changing the set of practices, right? Which means change management. And of course, there's a lot of resistance sometimes you get from the organizations, like, why do we change from our traditional software development to this particular process? So Patrick said that DevOps was a human problem. So it's not really a technology problem, but in reality, it's a cultural and business problem. So what is culture? Culture is a lot more than just a set of practices, right? There's a set of values, behavior. So culture exists when there are all kind of diverse people in the organization. Where are they coming from? What kind of background they have? So traditionally, when you develop software, what happens is you have a dev team and you have the operations team, right? And in between those teams, there's a wall, which means that once the development is complete, then the code is shifted to the operations side, and then of course moves on. And that's been really happening even with enterprise companies. So development again is in charge of creating features, and operations in charge of maintaining stability. All, basically there's a wall in between, right? So today, when DevOps entered, it actually broke the wall, right? So now teams have mutual understanding, they collaborate better, they can share information in real time. The processes are such that things are being automated all around. So this brings us to the CAMS model once again, right? So the A in CAMS, right, is the automation. So when we think of automation, we think, well, geez, just press a button and everything will be developed, right? So it's like that, but it's not, because underlying processes cannot be ignored, which are people and processes. So these are important. So if you're using tools like Chef, Puppet, GitLab, and any other tools, you think, well, hey, my entire software lifecycle is now being automated. But really, part of the point of this particular model is to bring back the balance, right, of people, processes, and they have to come first. And after people, over processes, right? And then you come into the automation aspect of DevOps. So once you begin to understand the culture, then you can bring in the fabric of automation into your systems or processes. So automation is then accelerated towards development and then eventually quality. So your primary approach is the automation eventually. And that leads us to the measurement, which is the ability for us to actually measure. So metrics, for example, to tell you what's happening, what changes are being made in real time. So there are two pitfalls of metrics. First, sometimes we choose the wrong metrics. And second, sometimes we just fail Totally. Because of this, DevOps advises that you measure the key metrics across the organization or across the life cycle. So maybe you want to look for mean time, cycle time, costs, and so forth. So all of these are part of generating different measures for you. And these metrics help the team in reaching the overall goal. And then of course, then we come to the shared, okay? That brings us to the S in the CAMS model. So sharing ideas is the heart of collaboration, and it's also the heart of DevOps. In DevOps, you place the premium on transparency, so to speak, which means that you are now introducing agile practices, maybe Kaizen, which is a Japanese term, and so forth. And I'm going to talk about a little bit more on the project management areas as well, so you not only get the flavor of the common DevOps fundamentals, but also some additional as a bonus flavor of the project management words, tools that we also use within the DevOps lifecycle. So I hope this helps. In this lesson, I wanted to focus on the shift, right, which is the more of a cultural shift in DevOps and the CAMS model as well. So if you have any questions, post them in the discussion area. I'll be happy to help with this. Let's move to the next lesson. Welcome back. Super excited moving forward. In this lesson, I'm going to talk about certain core principles within DevOps and how we can take our values of DevOps and bring them to actual in practicality or bring them to life. So the core DevOps values were, in fact, the most respected set of principles are known as the 3 ways. And this model was developed by, I believe it was Gene Kim, and I believe it was Mike, I forgot the last name, who was in Lean IT, right? So both the principles of Lean and then, of course, the concept of automation as well. So the 3 ways of is systems thinking, amplifying feedback loops, and then culture of continuous experimentation. So let's talk about the first way, which is systems thinking, which tells us that we should make sure, or we should focus on the overall process or the pipeline of DevOps. It's easier to make mistakes just to focus on one or try to optimize one part of the process, and that's really a mistake, whereas you need to think an overall process or results, because you're trying to optimize the entire application. And that way you're increasing performance and resources and automation. And you're also causing all of these bottlenecks to move in succession. Adding more application servers, for example, or hardware, database servers may not really help at times, because you will really need to understand the whole system, the flow, before you can start adding all these hardwares. So the deployment team might establish processes in their own ways that could increase their productivity. But those changes could compromise the development process, because even though that particular team in a set of tasks is getting more efficient, but that's really, creating a bottleneck for the rest of the areas in the entire flow. So you need to make sure that you focus on the overall system integration. And that way, you can reduce the defects, the errors, and the bottlenecks. This overall flow is called from concept to cache. So if you write all the software in the world and you can't deliver it to the customer, you're going to lose it, right? So the idea is that the split between development and operations has often been the place where this concept of cache goes wrong. Because use systems thinking to guide and define success metrics. The second way is amplifying feedback loops, one of the most important concepts. And that's all about creating short and amplifying those feedback loops between the parts of the organization and the flow of the value chain. The feedback loop is simply a process that takes its own output into consideration in deciding what to do next, and then where it actually came from. So short, effective feedback loops are the key to productive product development, software development, and operations. So for example, you want to implement certain project management practices like sprints or Lean Six Sigma principles, right? And that way you can actually take chunks of these processes, like using the agile approach, right? And then make sure you have an effective feedback loops built in to your software development process. So let's say you come across a simple bug, right? Let's say developers are working on an enterprise level software development and they find a bug. So once it's found by the developer, and before the developer checks into the source control, and the developer catches the bug right at their own desktop, you've just eliminated a lot of the additional processes. In other words, the bug is not going to go to the QA, it's not going to go to the ticketing system, and then eventually revert back to the developer. So now you've just eliminated the problem in a very short amount of time. If that bug gets past the developer and goes to the QA team and is documented in a ticketing system, for example, like I mentioned earlier, of course, it still resolves, goes back to the developer, but you waste time. But the third scenario is that the bug goes from the developer to the QA and then to the customer. And then the customer creates the ticketing system, right? So that means that now additional time is wasted. Because now the end users, which is the customer, is logging all these issues back to the developer, in essence, right? So think of the time being wasted throughout this entire process. So, of course, that wastes even more time, and more importantly, it wastes money, and with worse outcomes. So effective feedback is what drives any control design, right? You as a DevOps engineer or specialist or working on this entire management of the DevOps lifecycle, creating these feedback loops is, again, very important. And then you amplify these loops as well, because now you're actually creating multi-team processes, right? You're visualizing metrics and design and delivery flows at the same time. The third way reminds us to create a work culture in both continuous experimentation, delivery, and more importantly, learning, okay? So your team should be open to learning new things, new techniques, new areas. And the best route to that is really trying them out what works, which tool effectively, when implemented, works the best. So instead of falling into the traditional processes. So it's not just about learning new things, but also engaging your teams with continuous practices and acquiring new skills, which are already part of the portfolio. The idea is that your teams are the actual developers, or the QAs are the ones who are actually working on the software, right? So you need to make sure that they're not only delivering, but also learning at the same time, learning new skills. And the best way to learn new skills is obviously understanding the entire cycle and focusing on certain tasks that they're actually doing. And all of these developers in QA, by the way, they're pretty tech persons, right? So they understand technology very well. And they understand what the working code is, how does the code wins, how do we actually deliver fast. And that retains practical focus on the actual delivery of the software. So culture and continuous experimentation and learning process becomes or creates your processes more efficient, and also creates a collaborative environment, which is key in DevOps. So engineers and problem finders, solvers, that can often turn into one activity or technology into innovative practices. And that's the whole idea, that we, in this particular area of the DevOps lifecycle and software development lifecycle, both the operations and the developers, right? They work in harmony. So the goal of automation, so to speak, is really taking those processes and ensuring that less time is used to identify defects or bugs right off the bat before it actually travels across down to the pipeline all the way down to the customer. So I hope this helps understand these three key principles, apply them, as you move forward within your projects, they will certainly help you. So if you have any questions, post them in the discussion area. I'll be glad to help with this. Let's move to the next lesson. Welcome back. Super excited. Moving forward in this lesson, I'm going to talk about certain DevOps methodologies and how they help. Now, before I actually get into that, within the Agile project management, or within the project management field, in the Agile and Scrum approaches, we have certain laid down principles and methodologies that we actually use or utilize Agile practices so that we can make our processes efficient, right? Well, in DevOps, no certain set methodologies have yet been developed so far, right? Although there are, not a standard, so to speak, because it's dynamic. Every DevOps engineer or developer or QA or as a manager, you're creating your own methodologies. But of course, there are certain core or most popular methodologies that I'm going to talk about that help within the processes. And again, like I mentioned in Agile, there's sort of defined processes, right, that you can follow. In DevOps, and they're not really well established, but there are certain common ones that I'm going to talk about, right? So the 5 most prevalent methodologies I'm going to cover in this particular lecture. The first methodology is called the people over process, and I touched upon this in the previous lecture as well, right? So in short, it recommends that people are important. In other words, the job functions of people are important, their skill set is important over processes. So before you define the process, you need to take a look at the skill set that exists within the organization and how you can better fit a certain developer on a certain task or a QA person on a certain task. And then you select and implement the tool towards the process. So it seems obvious that engineers, they're bogged down into certain tasks, right? And they're wired into certain activities, and it's difficult for them to sometimes get out and then understand the concept of people over process. So the second methodology is continuous delivery. And that's such a common methodology that people think that continuous delivery means that it's just going to fly things, right? So we're going to click a button and everything will run smoothly. So in short, it is just a methodology where you're coding and then you're releasing software in a little bit of chunks. So really small batches, so you can control overall quality. It's been shown in studies that environments or teams spend about 20% less time when they actually are finding more defects, right? So your work slows down. And that's really something that actually ends up in a bottleneck. So when you have the concept of people over processes and you apply the second methodology, which is the continuous integration or delivery, that's where the efficiency comes in. So even maybe legacy environment. Let's say you start with the old printers, right? LaserJet or the inkjets to the LaserJets. So really, that's all of the processes, right? The third one is the lean management. Now that's a project management concept, right? So lean means eliminating waste, okay? And that's the typical definition of lean if you refer to the project management concepts. So that's all it is, and that's important for you to know. That if you are eliminating waste processes from the entire delivery pipeline, you've gained a lot of productivity, you've gained operational efficiency, and you've gained profitability for your organization. So lean, work in small batches, feedback loops, visualization are all lean techniques. So lean management practices are helpful if you apply them to DevOps or if you integrate these practices within the DevOps lifecycle, because you'll end up with greater employee satisfaction for sure. The fourth is change control. So change control is really eliminating repeatable artifacts, right? And managing dependencies, creating an environment of continuous improvement. And last is the fifth methodology, which is infrastructure as a code. The major realization is that systems can and should be treated like code. System specs should be checked with source control, reviews, builds, whether they're automated tasks, and that's where you can automatically create systems that run by themselves. And this kind of programmatic systems are efficient and helpful. So you're not tied down to certain set of core practices, but actually you're being fluid, right? So you're implementing all of these 5 methodologies within your processes to gain one common goal, which is efficient delivery of your software from design all the way to customer. And again, it starts with people over process and then so forth. So I hope this helps. Practice with these concepts. If you have any questions, post them in the discussion area. Again, if you're using these concepts within your DevOps environment, I'd like to hear about this. And if not, of course, any questions are welcome. So with this, let's move to the next lesson. Welcome back. Super excited moving forward. In this lesson, I'm going to talk about the tools that are used in DevOps. Of course, there are several tools that you can pick and choose. But more importantly, I'm going to highlight certain key areas for you to understand these tools and, of course, the core set of thinking before you're actually selecting any of these tools. So let's talk about what you want in a tool set. First, you would like the tool to play well with the other tools that are being used within the entire DevOps lifecycle. So it should be able to perform its work in an automated manner. It should, maybe fix a broken API or a command. Tools that are only UI driven, they sometimes prove to be a poor tool in the DevOps area, right? Because they may look fancy on the front end, right? The UI looks really great, but the back end functionality of the tool may not really serve the purpose. Second, you want the tool to be verifiable. So you need to verify the tool. In other words, you need to make sure that whatever the tool is actually doing is verifiable, right? You can backtrack. And the best kind of DevOps tool exposes clearly what it's doing, and it provides some kind of validation, right? And events and metrics within your tool are also important. Third, we have the tool that actually runs perfectly, right? Or is behaving well, as we say, right? It's not, it's minding its manners, so to speak. So you want a tool that is more efficient. So both from a developer point of view and operations point of view, you should be able to check the tool's configuration, source control, maybe tests, verify how does the tool behave, and more importantly, whether the tool can be deployed in an automated manner or not. So let's dive in a little deeper, and I'm going to talk about certain tools that I've used myself in DevOps practices and implementations. Welcome back. In this short lesson moving forward, I'm going to talk about certain popular DevOps tools that typically are used within the DevOps lifecycle. Now keep in mind, as we're progressing, of course, there are several new tools that come into the market, and then DevOps or enterprise architects or project managers that take a look at these tools, evaluate them, and then decide which one is the most effective in terms of integration, in terms of efficiency, and so forth. So I'm going to talk about certain basic ones, just 3 or 4 of these tools, so that you get to understand some of the capabilities and features. So one of the first tools that I like to talk about is the Innovate, right? E-N-O-V and then 8, which is a DevOps at scale. In other words, it's a platform that sits across the IT landscape or the infrastructure. That has applications, data, whether it's operations, infrastructure, your teams that are involved, both dev and operations, and also provides enterprise IT intelligence. So it's a delivery tool which is integrated and holistic command control that contribute to the overall delivery agility. So that's what this tool does. So this fits your environment perfect. Maybe you ought to use it or try it out. Some of the features, of course, are enterprise level dashboards and reporting. You can have individual team dashboards using this tool.
This DevOps tool is integrated well with the entire life cycle. DevOps events and deployment planning is part of this tool, standardization, collaboration. You can also do task orchestration and automation. And the good thing that I like about this tool, it provides lean service management, right? And self-service portals. So that way, this kind of uses the lean methodology and it tries to eliminate the waste processes. Next is the popular tool called Jenkins. It's a DevOps tool for monitoring execution of repeated tasks. So you can build the entire pipeline using Jenkins. It helps you integrate project changes more easily by quickly finding issues. So let's say a developer logs an issue and it's trackable all across the development pipeline. And what this does is some of the important features that increases the scale of automation. It requires little maintenance. So once you create a workflow in Jenkins, and I think I have a course on this too as well. So you can use the GUI tool for Jenkins and easily create a pipeline integrated with the backend, let's say Google Cloud Platform, if that's what you're using, like Docker or Kubernetes. And then you can integrate Jenkins as well. It offers several plugins that you can use to simply use to support your actual project requirements or the workflow that you're building. So it's a Java-based program and it supports CI/CD, which is again building the entire pipeline from start to finish, right? Continuous integration and continuous delivery. So the third tool is pretty neat. It's the AWS code pipeline, which is similar to Jenkins, and it provides a visual view of the end-to-end delivery process. So for instance, it will provide us the source code repository where you need to be either in AWS commit or you can use the GitHub repository. It also provides build service. AWS code build details will be configured as part of the pipeline that you're trying to build. And you can use deploy, code deploy, which will be configured into the pipeline itself. And during this deployment process to different environments, if any approvals are needed, they could be configured as well. So these are the important core features of the AWS code pipeline. So if you're using this, for instance, within DevOps and using your own workflow, so to speak, AWS code pipeline is also a pretty powerful contender. Chef is also a useful DevOps tool for achieving speed, scale, and consistency. So it's a cloud-based system, can be used to ease out complex tasks and perform automation. So again, similar to Jenkins and so on, right? So all of these tools may perform similar functions and features. So pretty much all of these tools kind of relate, right? As you've noticed already. But the key point here is that you need to understand how well the tool will be integrated in your own requirements as you're building your DevOps lifecycle. So this particular tool accelerates the cloud adoption, effectively manages data centers, can manage multiple cloud environments, and also maintains high availability. And of course, finally, the GitLab. This is one of my favorite tools. I've also created a course in using the pipeline of GitLab all the way to Kubernetes using the Google Cloud Platform. But this is where you can actually do auto DevOps, and it's a pretty fascinating tool that I've used. The only single product for the complete DevOps lifecycle. It's the leading integrated product for modern software development, connecting issue management, version control, code review, continuous integration, delivery, and monitoring, right? So everything is built into GitLab. So from project planning and source code management to your entire workflow, everything is done in a single application. So this makes or enables the software lifecycle pretty fast, right? Almost 200% faster than integrating different tools. GitLab also enables teams to collaborate and work from a single conversation instead of managing multiple threads across disparate tools, right? So here it is, you have one solid tool that you can use for your entire DevOps operations. GitLab provides teams a single data source, one single interface, and one permission model across the DevOps lifecycle. And this, of course, benefits the team. They can collaborate better, which eventually reduces the cycle time and provides operational efficiency. So in summary, the idea is the core objective is to understand all of these popular tools that I've talked about. And of course, there's several others that you can also take a look at. But more importantly, choose a combination of tools that fits your own project requirement, that provides you well integration, that provides you solid operational efficiency. So I hope this helps. Kind of take a look at this. If you have any questions, post them in the discussion area. And with this, let's move to the next lesson. In this lesson, I'm going to talk about briefly the history of DevOps, just so that we understand how does it all begins, right? And where it actually started, who started it, just to give you a flavor, okay? So just going to run through some of the important concepts or the history of DevOps. So here's the timeline. The first Agile conference, I'm going to talk about what Agile methodology is next, but just for now, there was a conference held in 2008 to discuss the Agile development infrastructure. Moving on, in 2009, John Alspaugh and Paul Hammond presented the 10 deploys per day development and ops cooperation at Flickr. Because remember, initially the traditional software development methodology is monolithic, right? So it's purely traditional. You have individuals or developers sitting in one room developing the application, and once it's all developed, then it's tested and so on. It's fixed, errors are corrected, and then finally it ends up in the release, production, and then release. Okay, so here bear in mind, DevOps is not something that just started last year. It has been around for almost a decade now. So after 2009, the same year in October, the DevOps Days was started by Patrick Dubois and primarily in Ghent, Belgium, right? So this is the place where it actually started. 2010, it spread globally. So the actual name of DevOps Days was spread globally, and tools like Puppet, for example, and Vagrant, Jenkins, they started to gain popularity. And today, by the way, Jenkins is one of the most sought out tools for DevOps engineers as far as the continuous integration is concerned. And 2011, in March, Cameron Haid of Gartner predicted explosion of DevOps in global 2000 companies, where he basically suggested that the next 5 to 10 years is going to be very important for DevOps. And here today we find the actual usage of DevOps being more and more within the enterprise level apps and software development. So we're certainly shifting from the traditional software development to more of a DevOps environment. So what is Agile? I talked about briefly, I mentioned this word earlier, Agile. Agile software development refers to a group of software development methodologies based on iterative development, where requirements and solutions evolve through collaboration between self-organizing cross-functional teams. By the way, the opposite of Agile, or another methodology I should say, is the waterfall approach, which is simply step-by-step process, right? So you finish step A, then you go to step B, then you take step C, and so on. So think of the waterfall approach as descending or ascending on a staircase, whereas Agile is an iterative development. So you go back and forth, right, between the dev teams, the ops teams, and so on. Agile methods or processes, they promote a disciplined project management process that encourages frequent inspection and adaptation. It also provides a set of engineering best practices intended for rapid delivery of high-quality apps and software, and a business approach that aligns development with customer needs and company's goals. And that's why Agile methodology is by far currently being used in the software development industry. Not to say that we can't use waterfall, but still, at times, this becomes important. What is Scrum? I would like to highlight this term because within the DevOps arena or the environment, you are going to hear terms like Scrum, especially when you're into the software development area. So Scrum is simply a subset of Agile. It is a lightweight process framework for Agile development, and of course it's the most widely used one. That's why I like to highlight this term Scrum, so you understand what Scrum is. So again, it's just a process framework and is a particular set of practices that must be followed in order for a process to be consistent with the framework. So for example, the Scrum process framework requires the use of development cycles called sprints. So developers, we work in sprints. We do sprints, in other words, we create a set of code and then we create another set of codes and so forth. So everything happens in sprints. And that sprint could be a week long, could be 4 days, could be 3 days, depending on the type of app or software that you're developing. The lightweight term means that the overhead of the process is kept as small as possible to maximize the amount of productive time available for getting useful work done. So Scrum significantly increases productivity and reduces time to benefits relative to the classic waterfall approach. Scrum processes enable organizations to adjust smoothly to rapidly changing requirements and produce a product that meets evolving business goals. So very, very important. And of course, as a homework, understand Scrum. Take a look at what this is. Read more about it. Post it into the discussions area. I'd like to hear from you as to what you understand of what Scrum is all about. The Agile Scrum benefits: increase the quality of the deliverables, cope better with change, provide better estimates while spending less time creating them, and be more in control of the project schedule and state. So several key benefits that this methodology and framework provides. Wait, what about DevOps, right? How does DevOps fit into the entire picture? So apart from working together as cross-functional teams of, let's say, designers, developers, testers, ops team, DevOps suggests to add operations as well in the definition of the cross-functional team. So this is where the benefit of DevOps comes into play, where you're actually merging the ops team with the development and the rest of the teams. So DevOps also strives to focus on the overall service or software fully delivered to the customer instead of simply working software. So the customer is not only going to get the end product, but actually that software has been fully tested, fully fixed, iterated several times among different teams, and so on. DevOps also emphasizes breaking down barriers between developers and operation teams and getting them to collaborate in a way where they benefit from combined skills. And this is very important because in my experience we have teams sitting in one office developing software. You may have the ops team in a different area and they're going back and forth, emails, meetings and whatnot. Time is money. So DevOps essentially will reduce their time and costs and risk too. So DevOps brings some tools like configuration management, Puppet, Chef, Ansible, orchestration tools like Zookeeper, for example, monitoring and virtualization tools, containerizations is very important, and platforms like Amazon, Kubernetes by Google Cloud, for example, and Docker. All these tools help aid the DevOps environment. So in this lesson, just want to talk about briefly what the history of DevOps is and how DevOps fit into the entire picture. So practice with these concepts. Hope this helps. Let's move to the next lesson. All right, moving forward, I'm going to talk about the DevOps metrics. So no discussion is really complete without talking about some of the DevOps metrics, which is the agility and the reliability. So we'll take a look at what those are in this brief lesson. So in this DevOps metrics, we have the agility performance indicators, which are the first two on the left side of the screen, the deployment frequency and change lead time. And then we have our reliability performance indicators, which is the change fail rate, and then mean time to detect and repair. So I'd like to take a look at these four metrics, which are primarily divided between the agility and reliability. And these four metrics really reflect on how good of a job we're doing at bringing the DevOps within the organization. So let's take a look at the deployment frequency first. How quickly are we actually deploying? And let's measure our deployment frequency, not just into production, but also measure it into all of the other environments as well. Dev and test and user acceptance testing, for example, the next agility performance indicator is the change lead time. So for instance, if we have to change our software code as we're developing our applications, we need to know how fast can we get that into production. And of course, we can use the lean methodology, and it's a famous saying where it says, deliver faster than your customer can change their minds. That's the idea. So in order to get there or reach this objective, we really need to measure how quickly we can get a change from a developer's mindset through the process and safely into the production environment. So let's talk about the operations as well, because this also includes operations, but the next two metrics are more closely aligned to operations metrics, which they are, and they are some of the reliability metrics. So the first one in this group is the change fail rate, which is basically how often do we fail when we try to push out a new change. And of course, you need to recall that the objective and the DevOps goal is to become more efficient and effective at delivering these small increments of value into different environments, including production. So ideally, the fail rate goes down and further down until it gets to a point where going into production, it is really not a big deal. And that's something that just happens. Now the last metric that I like to highlight is the mean time to repair, mean time to detect, which can be, of course, MTR if you want to abbreviate this. And this is for the realize, recover, repair, and remediate steps. And basically what these metrics do, they give us how quickly are we catching on what's production or what's happening in production, finding out that someone is bad, recovering from it through some workaround, or another way, maybe through a hack if we have to, or maybe another workaround that someone just came up with, and then getting it back through the dev cycle to repair everything. And finally, the remediate and figure out really how to make sure that the class of errors won't happen again. So we learn from our experience as we get into the automated testing environment through some changes to our architecture. So these four metrics, they basically go hand in hand and they tie in together to reinforce one another to make sure that you've got a balanced set of measures that can help you towards a good DevOps environment and of course with the DevOps culture as well. So that's the idea behind these four metrics, which is agility and reliability, and each of these sections have two metrics that fall into agility and the other two fall into reliability. So I hope that makes sense. Just go over some of these metrics. These are important as you move forward and try to gain a solid understanding of the DevOps fundamentals. And with this, let's move to the next lesson. Welcome back. Moving forward, we're going to talk about how agile software practices apply to the DevOps arena. So in this brief lesson, I'm going to demonstrate different agile methodologies and certain principles that the industry-leading practitioners have put together as an alliance. And we'll take a look at what those principles are. I'm also going to assign you some homework in order to understand these principles because these are self-explanatory. But I'm going to highlight some of the basics and fundamentals just so that you get a better understanding. So, revisiting the Agile Manifesto, we are uncovering better ways of developing software by doing it and helping others do it. Through this work, we have come to value. And once again, who is this we? We're talking about this Agile Alliance. And you can visit agilemanifesto.org or .org and read everything that you need to know about the Agile methodology. So, group of Agile industry practitioners have gotten together, they have put their heads down together and really laid down the principles of Agile methodology. So, throughout their experience and their past work, they have come to value individuals and interactions over processes and tools. So, most focus today, for example, in developing software or writing software apps, is on processes and which tool to use. Whereas the real impact has to be on the individuals and interactions among those individuals. So you have a dev team, you have an ops team. So what goes between them is really what counts. So working software is another one, for example, is important over comprehensive documentation. So you can have all the documentation you need, but if the software doesn't work, the documentation is useless, right? Similarly, customer collaboration over contract negotiation. So you can have a good contract, but if the customer is not willing to collaborate with you, so for example, your software methodology or the software that you're developing for the customer is not at par, or the customer may be thinking in a different manner. So the written contract would have no value, really. So these first three are important. Then we have the responding to change over following a plan. So typically, obviously, we lay down a plan to develop a certain app or software, to use certain methodology, moving forward into development and production. But guess what? In a practical manner, things change. We live in a dynamic, fluid world, right? People come, people go, minds change, technology changes, and so on. So the response to that change should be taken in a positive manner, instead of just sticking to the plan and saying, well, you know, we wrote this and now we're going to follow this, right? So we need to kind of understand that the value of individuals and interactions, working software, customer collaboration, and then responding to change is important. Here are certain principles that are behind the Agile Manifesto. So there are several principles. Obviously, the screen is full, right? So I'm not going to go over these. I just want to show you these and highlight certain important ones. For example, welcome changing requirements is the second one down on the left side of the screen that I want to highlight. You can always read on the website on the agilemanifesto.org, or you can take a look at these and kind of go and understand each one of these. And this is your homework, by the way, guys, right? So you need to understand these. You need to take a look, understand what these are, what these principles are, kind of get them in your head, practice. And I welcome the discussions in the discussion area, right? So that's a great way to interact with other students and myself if you need certain clarity. But I'm going to highlight the second one, which is welcoming change requirements, even late in development. And this is fairly common in my experience as well. You're almost done with the software development, and guess what? Well, we need this thing added. So the Agile processes harness change for the customer's competitive advantage, because the customer is really looking to gain a competitive advantage while developing this software or software app. So we need to be able to cater to this. The second principle that I think is important in this list is on the right side of the screen, which is Agile processes. They promote a sustainable development. The sponsors, developers, and users should be able to maintain a constant pace indefinitely. So this is important, and this again comes back to the communication and the interaction among the teams. And this is where DevOps plays a very, very important role in getting all these teams together under one page so that eventually the customer benefits. And you can take a look at the rest of these as we go along. Moving forward with these principles, the highest priority is, of course, to satisfy the customer, because guess what? The customer is always right. And that is, once again, through early and continuous delivery of valuable software. You want to be able to deliver working software frequently, from a couple of weeks to a couple of months with a preference to a shorter timescale. Business people and developers, they must work together daily. And I want to stress this word called daily throughout the project. Not weekly, not twice a week, not thrice a week, every single day. Business people, for example, your business analysts and the developers, they must work together daily. The BAs, for example, they need to be able to see the software in action, what the developers make. And then working software is the primary measure of the progress. So the agile operations, you need to know the source control, the small and frequent releases is important. Automated testing is an important area. Continuous integration and deployment is part of the agile ops. And then peer review and immutable infrastructure. So these are all a list of agile ops that I put together. Again, once that is part of the agile manifesto that you can take a look at and work with. And finally, the benefits of smaller releases. So the smaller number of releases over time lowers the risk, because these releases they go through the dev process, the QA process, for example, or to the customer just to take a look at when you're in the UAT phase in the project cycle and whatnot. So it lowers the risk, so you can correct and fix things as you go along, instead of developing the entire set of software, handing it over, and then finding out, well, it doesn't work. The other benefit is faster feedback. So small chunks will give you better feedback. And thirdly is more confidence. So developers are more confident that the software is working. So in this lesson, I just wanted to cover some of the principles of Agile and, of course, go through the Agile Manifesto. And don't forget your homework. Go through these principles and put forth your questions in the discussion area for other students and for myself. With this, let's move to the next lesson. Welcome back. Moving forward, I'm going to talk about another important concept, which is called source or version control when we're developing software. So both of these terms are used interchangeably. So sometimes it refers to as version control or source control. So let's take a look at what these are and how important they are in the field of DevOps. First, let's take a look at what version control is, right? So it's basically a system. Think of this as a system that records changes to a file or set of files over time. So it's similar to, for example, changing or saving a document as one version, then you make changes to that document, and then you save it as another version, while you still keep the previous version so that you can restore from backup, for example, right? So you get the idea. So version control is just a system that records changes to the file or set of files over time that you can recall specific versions later. More specifically, why should we care about version controls? Why is it important when developing software or apps? So, like I said earlier, we can recall specific versions of that particular piece of code that we created. So for example, if you're a graphic designer and you want to keep every version of an image or layout, which you would most certainly want to anyways, so the version control system is something that you would like to implement and you want to use. It will allow you to revert back to those files in the previous state. So that's the concept of version control. So let's talk about the benefits of version control to DevOps. So now every version control is one of those things that sometimes, again, like I mentioned, is called source control, and these terms are used interchangeably. So what is source or version control to DevOps? It's basically the management of changes to documents and computer programs, source code, large websites, or any other collection of information. And that's exactly what that is. Another benefit is that you can compare two versions. So you don't have to worry about the changes. You can actually pinpoint the differences between version A, for example, or version B. Moving further, it also allows for parallel development. So this is sometimes referred to as, for example, you may have two teams working on certain software. One team is developing a certain set of code while the other team is developing another set of code. So you can compare those two versions, and it allows for parallel development. And later you can merge those changes into one set of code. And as far as DevOps is concerned, I'd like to highlight one of the key players in our DevOps industry, Gene Kim, for example. He hypothesizes as to why a high number of failures in real life are due to misconfiguration of the environment itself and not the bad code. Because notice, as software developers are coding the actual software, it's not about the code. The code can really be fixed and can be identified and fixed and then tested. But the misconfiguration of the environment, or the impact of the environment, or the management of the environment, is what really counts. How well both of these teams are working together. For example, the dev team, the quality assurance team, for example, in both of these environments. How well these two teams coordinate. So if you've got all of the configuration in your code, it means that when you deploy, you're automatically running the configuration from a script, which essentially means that there is no possibility of any additional misconfiguration. So if something was to go wrong, for example, you can easily troubleshoot, find the changes, and then fix the code. And it also allows you to recreate absolutely any of your environments solely from what's in the source control. And I'd like to highlight an important aspect here, that when we're looking at source control or version control, not from the developers that are in the source control and the operations team that are involved in the same environment. They're basically in the same source control. And here's why. So I want to be sure that when I'm rolling out a new version of the software application, that the environmental configuration, for example, for that new version rolls out with all of the changes, right? And if for some reason we have to revert back or roll back our changes, we just go back and get the earlier version of the code and automatically get the earlier version of the code, the earlier deployment scripts, and the earlier environmental configurations. So basically everything works as planned. So the idea, the goal is to basically get back in time, right? So if you're using version control or source control and you've deployed using a tool, for example, you can always refer back to the previous version. So once again, in this lesson, I just wanted to highlight the importance of using version control, and then the importance of your actual environment where the software app or the software is actually being developed. And it's important to keep track of these versions. You can always revert back to them and take a look at what you actually missed, fix it, and then move forward, and then of course go back and forward. So it's an iterative process of using version controls as you move forward into development. So what DevOps does essentially is controls the environment. It brings both of these teams together under one platform, and using version controls, whether you're using a singular version control atmosphere environment or you're using a distributed version control environment. The goal of DevOps is to bring everyone on single page, single environment to work seamlessly together with the bottom line of benefiting the customer and deploying an efficient app. So with this, let's move to the next lesson. Welcome back. Moving forward, I'm going to talk about DevOps automation. So we'll take a look at different processes that we can actually take and how to automate them. In fact, also observe various tools that are available for us to use. So first, the concept of automation, which simply enables continuous value delivery. So the whole idea is to automate all these tasks from developer to release. So for example, starting from the left, we have our developer coding the application or coding the software, generating different version controls. Then we move towards build and unit testing of the software. We get into automated acceptance testing. And then of course the UAT phase or the user acceptance testing comes in. And finally, the software is or the app is released. So each of these processes obviously are done by individuals, right? And they're done as an iterative process, going back and forth. There are multiple teams working on this, different departments maybe, and these could be geographically dispersed teams, not just sitting in one room, because remember, monolithic applications or traditional software development entails that everyone sits in one room, creates a software, and then ships out to the customer. But with large enterprise organizations or distributed environments where you have teams that are spread all across the world, for example, it's difficult to manage. So to enable DevOps to have an automated continuous value delivery, we need to take a look at different tools that are available as well. But before I talk about tools, just once again, quickly, we start from the developer and we end up in release. And the chart shows on the bottom here, you'll notice that we go back and forth, we get the feedback. So for example, if the developer writes a code, creates a version controls, that goes into testing, well, there are certain errors, right? So it's reversed back to the developer. So this is how we go back and forth until finally we get the approval of the final release of the software. So the whole idea is to achieve full automation. Some of the benefits of automation in DevOps before I dive into and show you different tools that are out there. So one of the benefits is obviously it removes manual errors. So the more you automate, the easier your life will become. It also enables anyone to perform tasks. So no matter where the person is situated, it's easier in an automated environment. It enables speed, reliability, and consistency. And of course, empowers frequent releases and self-service. So we know that there are several benefits attached to an automated DevOps environment. So your goal is to create such teams and have such an environment. Recall from our previous lesson, I emphasized the fact that environment matters a lot. So if you build an environment that is conducive to an automated software development, then you are going to have a wonderful and more efficient and effective delivery to the client. So keep in mind when we talk about the benefits of automation in DevOps. The tools for automation in DevOps. So I've listed only some of these tools that are common. You can visit their websites and take a look at and explore all of these tools and what they do. But commonly it's Puppet, PowerShell, DSC. You can use Chef, Azure Resource Manager, Kubernetes, and Docker. So in my course where I talk about Java and Kubernetes and Docker, and in fact show you how to deploy and create all these apps and deploy a live app using Kubernetes and Google Cloud, including Docker images, you will see that these tools in fact automate the entire environment. We can create VMs or virtual machines, for example, create clusters, and have the failover environment where if the application fails or the images are not loaded, what happens, right? So the entire process can be automated. But here, for the purpose of this course, since we're doing just the fundamentals, you just need to know some of these words and buzzwords and these softwares and tools that are out there. So basically, these tools enable automation for almost any task that is typically performed by the operations staff, from provisioning and configuring machines, like I mentioned, virtual machines, creating clusters, to configuring networks and firewalls, to monitoring and correcting configuration drifts. So all of these tools are very, very handy. What to automate is an important question. We build and deployment, right? So you need to automate the entire process from build to deployment phase. The environment creation is very important. Once again, you need to be able to automate that environment. Infrastructure configuration, unit integration, UI, and performance testing also needs to be automated as much as possible given the underlying conditions or your scenario. Document generation, there are several tools out there you can use to automatically generate documents such as user guides, admin guides, technical guides for the end user. And of course, monitoring and notifications can also be automated. So the entire idea is to take your DevOps environment, both operations and development, right, and automate it fully. So I hope this helps. Practice, and as a practice task, just go through these software that I listed in the previous slide, like Kubernetes, Docker. Take a look at, understand what these are. Post them into the discussion area. If you have any questions, just feel free to ask. I'll be more than happy to answer. So as a practice task for this lesson, I would like you to explore Kubernetes and Docker and wait for your questions in the feedback area. So let's move on to the next lesson. Welcome back. Moving forward, I'm going to talk about in this lesson unified processes between dev and ops. So you have two teams. You have the development team and you have the operations team. We'll take a look at, in the next 4 slides, how do we actually create a unified process between these two teams. So the first thing that we need to know about the unified processes between the development and the ops team is that the value collaboration between these two teams should be right from the very start of any project. So you can't really begin the development of the software or the app, right, and then bring in the ops team to do their part. You need to pull them together at the same time and then lay everything out on the table so every individual understands the processes and the entire environment that you're trying to automate. The second step is develop a production first mindset. Not a development first mindset, but rather a production first mindset. So keep that difference in mind. So every piece of code should primarily be developed with the production in mind. And what do we mean by this? Just a few things, right? So for example, like how will this be deployed? How will we test the software? How will we monitor the software? And so on. What version controls are we going to use? And this version control, everything should be included in that, like configurations and deployment scripts and so on. So in order to build a unified processes between dev and ops, we start off with these 4 things. Moving forward with the unification process, we next automate everything, especially the manual intensive tasks. So you want to focus on those tasks that are manual and just automate them using different tools. And the more you can automate, the better it is. The more stable the application will be, the environment will be additionally be more stable, and repeatable software delivery becomes easy. So the repeatable tasks, for example, that can be automated. You can free the teams to work on more important things. You can create small, frequent deployments of code and configurations. And all of these are, of course, part of the unification process between dev and ops. Next is the deployment of smaller changes. And we've talked about this earlier as well in one of our previous lessons, where if you deploy small increments of change, it's easier to control and monitor and then correct, which primarily leads to a faster mean time or remediation, right? Since fewer things are impacted when doing small deployments. So small, frequent deployments decrease the amount of time it takes to get feedback. And we know that the faster the feedback is means better decisions about what to build next and how to fix things. And monitoring, logging, version control, source control, and validating performance repeatedly is a good practice. And finally, a few additional things to remember while you're trying to unify the process between dev and ops is with more deployments, teams need to have more detailed knowledge of what is happening with application in production. Good telemetry leads to proactive adjustments. So for example, scaling out during peak time periods and scaling in during low periods of activity, improving the usability and saving costs for the enterprise. And let me give you an example. So for example, if you're using Google Cloud Platform, Kubernetes, or you're using the Amazon Web Services to deploy these apps using Docker, for instance, all of these platforms, they allow payment by usage. So depending on your usage of the app, they bill you accordingly, right? So you don't have to pay a fixed amount. So that's the good part. So if you deploy something in Azure, for example, so Microsoft is only going to charge you for the usage. So that's a good thing. So you can make these proactive adjustments based on the app or the software that you're developing. So good telemetry also allows deep insight into application and customer requirements and needs, feeding back into the backlog of your development. So if you follow all of these processes, you are going to get a unified environment between dev and ops. So practice with this, go back to these slides, try to understand, and as a homework, I'd like you to create an environment and come up with additional thoughts that you think can actually be useful between the dev team and the ops team, and post it in the discussions area. So I hope this helps. Let's move to the next lesson. Welcome back. Moving forward, I'm going to demonstrate hands-on the concept of using Git, right? So it's different from GitHub. You may have heard the terms GitHub, where you can fork the repositories and take a look at different software codes from various people. But Git is simply a free and open source distributed version control system that is designed to handle everything from whether it's a small project or a large project with speed and efficiency. So relatively easy to use, but the purpose for this course, since this is DevOps Fundamentals, I'm just going to show you the tool and basically what it does, how does it work, just at a high level, right? And I'm going to assign you some homework so you can actually go ahead and download it, take a look at it, play with it, understand it more, and learn Git. Because if you're into DevOps, you will need to know Git. It'll be very handy for you in bringing the dev and the ops teams together, especially for distributed version control system where you have large teams who are spread across the world or different locations maybe, and this would help. Okay, so all you have to do is just navigate to git-scm.com and you will be seeing this page. Here you can download the version for Windows, for example, or you can try it online as well. So I'm just going to demo a couple of things about Git, and then you can later on practice with this. So I'm going to click on Try Git, and this is going to take us to a page where it'll give us an online version of some Git commands that I can actually use. So if you start practicing, notice once you download the Windows version or the platform that you're using, whether it's Mac, you can start playing with it. So the commands are pretty straightforward. It kind of tells you what commands to use. I notice I've begun to use the commands from an initialization phase to checking the status, to adding and committing changes, adding changes further, checking for those changes, committing them again, and adding all changes, and so on. So we can continue to take a look at the future commands as well. So here are the commands as a sample exercise, so I can practice and say git commit. I'm just going to retype this -m, and then of course add all the octocat txt files, because I've already added those files in my previous step. Hit the enter key, and it's going to execute this command and add the octocat text files. So again, not to worry, just give you an example of how Git works and how you can use this to commit the changes, track versions. So I can do something like git log, for example, and it'll give me the log as well. And I can continue on building each one of these. So you can practice on your own. I just wanted to give you a flavor of what Git is. It is an open source version control system. So I will leave you at this, assign you some homework. If you have any questions about Git, just place it in the discussions area. I'll be more than happy to help. So with this, let's move to the next lesson. Welcome back. Moving forward, I'm going to talk about the basics of continuous integration versus continuous delivery within the DevOps arena. So these two things are essentially that actually makes up the DevOps environment possible. So let's jump right in and take a look at what these are and try to understand the basic fundamentals of continuous integration versus delivery. So first, let's talk about what is continuous integration. It's simply the practice of merging all of the developer working copies to a shared code line several times a day and validating each integration with an automated build. So all these developers are working on different pieces of code. So think of this as a tree branching out, right? So the code is getting messier and messier and everyone is writing its own set of code. So we need to validate each of those integration with an automated build. And then of course, using unit tests, which are generally executed during the build. So in practice, in all practicality, CI is often defined as having to build with unit tests that executes at every commit to version control. And we talked about version control in last lesson. So this essentially provides not only confidence in individual branches, but not on the integration of all the code changes. So you get the idea of the continuous integration practice. It's simply a merging of all developer working copies to a shared code line several times, several iterations during the day. So here's a visual representation of continuous integration. Notice the left part of the screen where it's developer, version control, and build and unit testing. I've highlighted this so you can actually see, and we use various flags as well as we move along through this process. So the continuous integration is, again, developer writing code, checking up, and then you doing the build and unit testing. Whereas later on we'll see when we get into continuous delivery is a whole different ballgame, because the delivery would involve automated acceptance testing, for example, partially unit testing as well, and then the user acceptance testing, and then the release. So we'll take a look at that a little later. Right now, just the concept of continuous integration. Quickly, the advantages of continuous integration: provides quick feedback for code quality. There's a trigger for automated testing for every code change. So every time something changes, there's a trigger, and then we test the code. Code analysis and technical debt management is one of the advantages. It also reduces long and difficult and bug-inducing merges, right? So it also helps streamline the code itself, and increases the confidence in code long before production. Next, I'm going to talk about the continuous delivery. This is the second element that gets into the DevOps environment. So what is continuous delivery? It's simply an approach in which teams produce software in shorter cycles. We talked about that, right? Remember the cycles where it can be long cycles versus short and streamlined cycles. So this is where you would actually have software or code in short cycles, ensuring that the software can be reliably released at any time. It aims to build, test, and release software faster and more frequently. Hence the name continuous delivery. Because if you have small chunks of code, it's easier to deliver. It also reduces the cost, time, and risk of changes by allowing for more incremental updates to production. In practice, continuous delivery focuses on an automated deployment pipeline This may have one or more manual approval gates. Of course, you can have managers or developer managers giving approvals at each stage prior to reaching production. But the core idea, the main point here is that you need shorter cycles of code and then continuously developing and testing and moving that further into the development pipeline all the way to the release area. So quickly, the difference between continuous delivery versus continuous deployment. The deployment is generally defined as a delivery pipeline with no manual gates between the initial code, where it starts, to all the way to the production. So we use flags, which are commonly used in both patterns, but they're not often necessary for continuous deployment. And these feature flags simply ensure that the code deployed to a production environment is not necessarily released to all end users. In other words, deployment does not mean it's release ready. This also allows for more mature features to be enabled in production, typically through configuration, while newer features can be switched off for most users. So we need to understand the difference between the continuous delivery versus continuous deployment. So there's a fine line between the two. So here's the continuous delivery, which is again the second half of the DevOps environment. So here in the continuous delivery mode, we're using some part of unit testing, and of course the acceptance testing is also included, and then the user acceptance testing, or also known as the UAT. And each stage has its approval mechanism built in. Few advantages of continuous delivery. It enables automated testing throughout the pipeline, provides visibility, feedback cycles are much faster. It also allows and makes going to production a low stress activity, because all you're doing is you're pushing out smaller chunks of code as opposed to large sets of code. And definitely increases confidence in code long before production, which is a similar advantage to that of continuous integration. So when you combine both continuous integration and delivery, you get a seamless DevOps environment. So hope this helps. Practice, go through these concepts again of continuous integration and delivery, and then kind of imagine how you can put these two concepts together into one environment to create an efficient and effective DevOps environment. And of course, post your questions in the discussion area, do some more research, understand these concepts. Any questions, just let me know, and then I will be happy to answer those. So with this, let's move to the next lesson. Welcome back. Moving forward, talking about the DevOps environment and the fundamentals of DevOps, let's talk about the continuous testing, which is an important area that kind of falls almost seamlessly in between continuous delivery and continuous integration, right? So it goes hand in hand and plays a vital role throughout the development process. So what is continuous testing? What do we mean by the term continuous testing? Think of this as simply execution of tests that are done iteratively or repeatedly against a code base and deployment environment. So could be an automated unit integration, coded user interface, and load tests that are common, or depth of testing often progresses an environment, gets closer to production. So just a series of tests. For example, if you develop a software that contains different fields like first name, last name, address, city, state, just a simple example. So what the execution of tests or testing would entail, that all the properties of that field are as per the document or as per the stipulated requirements or not. So when the tester tests that field, it kind of goes back and forth and ensures that it complies to the requirements, right? And that the developer has also developed or created this field correctly. So just going back and forth in different tests. So in practice, continuous testing is the most difficult part of a continuous delivery pipeline to keep up to date. And of course, the reason why it's a little difficult, because the QA tester, for example, the quality assurance tester, would have to go back and test each line by line, or let's say you have a form, right? As in my example, first name, last name, the QA would actually test each of those fields. Here are the different types of testing that are typically used. There are several others, but I've only highlighted the important ones. The first one is the unit testing, which simply tests the units of system in isolation. So you pick up a field, for example, on that form, and then you test that. And you go one by one and progress further. Then we have the integration testing, which is testing components together in different scenarios, whether the entire form works or not. How is it integrated with the next form or next scenario, okay, within the workflow and so on. The third type is the user interface testing, which is the user experience, testing components together in scenarios through the UI. So now you're the end user and you're working through that form. How does that form actually look like? What is the experience that the user would face? So that also falls within the testing area. And importantly is the regression testing, which is simply a type of testing which verifies that the software being developed, which was previously developed and tested, still performs correctly after it was changed or interfaced with other software. So this is important because you end up developing the software and then guess what? The scenario changes or the requirements may change. You talk to the client and the client says, well, can you add this particular functionality to the software? So you have to go back to the drawing board, right? So the developers redo the software, recode the software, or add more to the software, and that's where the testers would have to come back and then retest and make sure the software works, and that's regression testing. So very important, the types of testing. Just kind of go through them, and as a practice task, take a look at of all of these are and kind of understand and write some discussion area. I like to get some feedback from you as well as to what you understand by these types of testing. So the continuous testing, visually you can see that it falls within the build and unit testing all the way to UAT phase. So this is the area where you would be continuously testing, or the QA department or the team would be continuously testing the actual code or the software. And finally, the benefits of continuous testing: simply it ensures quality gates throughout the pipeline, and it increases confidence in code long before production. So with continuous testing, the end results are great and you'll have a seamless piece of software being produced towards the end because it's reiterative. So think about this, right? Because we talked about continuous delivery and deployment and then continuous testing. So within the DevOps environment, everything is kind of meshed together, right? And that's the idea. The best part is to automate all of these areas, right? So all of these segments, so that your software or app being developed is a fully integrated app. And this is where when we talk about DevOps, we talk about using technologies like Docker, for example, where you are loading images, you're building enterprise apps. So if there's a failover, it still updates the actual, or still holds the website and does not allow the website to crash, for example. Other scenarios would be, for example, you're creating different clusters within the VM clusters that we earlier talked about. Using Kubernetes, for example, is a great tool in the Google Cloud platform. You can use Jenkins, you can use other tools as well in different platforms. So the whole idea of DevOps is basically, instead of having independent teams, getting all these teams into one area, or let's say one room, right? so to speak, so that you can have a seamless way of producing and continuously updating your software. So practice with this, understand these concepts, provide some feedback, do some research. Students benefit from each other, right? So if you find something, be sure to post it in the discussions area. Hope this helps. Let's move to the next lesson. All right, moving forward, I'm going to briefly talk about just a few slides about configuration management within DevOps. So what this really means when we talk about configuration management, it's simply the management of the configuration of all of our environments for a typical application or the software that we're developing. So let's take a look at what it actually is. So the configuration management is, once again, the configuration of all the environments for an application. And typically, this could be in the form of scripts and can also be version controlled. So for example, versions of environments, versions of code, the versions of way the machines themselves are configured, for example. And these are very formal configuration management tools, and those tools, for example, you might be able to, or you're maybe well aware, in the operations world. And we're not taking away from those tools in DevOps. Those are still very important tools that we can use. But in the DevOps world, much of what we have a preference for is lighter weight, executable configurations that allow us to have basically configuration and environments as code. Okay, so these are less formal than traditional configurations, lightweight configurations. So they emphasize encapsulation of configuration in code over formal documentation. So that's typically what we mean by configuration management. Few benefits of infrastructure and configuration as code. It allows configuration to be version controlled, detects and corrects configuration drifts. It also treats infrastructure as a flexible source. So you can add VMs, you can remove VMs, for example, or hardware itself. Facilities automation is a great benefit of infrastructure and configuration as code. It also enables automated scale up and scale out. So as your app grows, as your software grows, you can scale up or scale out depending on the growth of your application. And more importantly, it provides the environment consistency. And that's important because as we move to the cloud, right, every software or the enterprise world is organizations are moving to the cloud. The software being developed is for the cloud environment. So having a solid understanding of DevOps and understanding the fundamentals, how to put things together, for example, how the teams work, how to seamlessly integrate the development team, the production team, the testing team, and so on into or under one platform is really a challenge, and that's something DevOps is here to answer. So several benefits of infrastructure and configuration as code. So just brief lesson, just wanted to highlight what configuration management is within the DevOps area. So I hope this helps. Let's move to the next lesson. Welcome back. Moving forward, once again briefly, I'd like to highlight the concept of release management and how it functions within the DevOps environment. So what is release management? It's simply managing what is deployed, where and how. So for instance, we can start off with the what, right? Which versions of components are being deployed? Where would entail which environment is being deployed to? And how could be automation and scripting to configure the environments and deploy applications. So it's release management is simply managing what is deployed, where and how. The less formal approach, which is the release management, is far less than the traditional release management approaches. It emphasizes quick and consistent delivery over formal change control. And that's the whole idea for the DevOps environment. You want to have the ability to have small increments of value that we talked about earlier, right? So small changes in code being deployed faster and faster. The QA or the testing environment or the department or the QA testers are actually testing the code back and forth in an iterative environment so that it's being efficiently developed. So therefore, it's less formal, right? So when you actually do a release, it's just managing what and where, which versions of components you want to release, and which environment from. So the benefits of release management: auditing and traceability, because it's easier to manage. Smaller pieces of environments, version controls, chunks, test environments, whereas if you develop a full-fledged, huge piece of software, it's very difficult to go back and forth. It also helps in automation, so you can automate individual processes. Allows for greater visibility for entire teams, provides confidence through consistency, and of course also at the end produces a higher quality result. So the release manager, for example, within the organization would be responsible for managing all of these areas for the release of the software or the app itself. So I just quickly wanted to cover the basic concept of release management. So as a homework, take a look at all of these areas that the release manager has. For example, the job function of the release manager. I'd like for you to go ahead and do research into what is the job description for a release manager. What is the purpose and what does the manager do? So this is your homework, so take a look at that, post it in the discussions area so that other students can actually take a look at, and any questions you can let me know as well. So hope this helps. With this, let's move to the next lesson. Welcome back. Moving forward, I'm going to talk about application performance monitoring, also known as the APM, within the DevOps environment. So what is this APM? We can monitor applications in different ways, and I'm going to talk about tools next, but before I in fact show you and discuss these different tools that are used to monitor our applications, first let's take a look at how and why we need application performance monitoring. So monitoring is obviously, we're learning from our live site, how it's functioning from the user experience perspective, and of course from the bugs or any other errors that we're experiencing on our live website, app, or software. So monitoring helps us do diagnostics and error reporting. It also provides usage, notifications on applications performance is also part of the monitoring aspects. Some of the rules for application performance and availability: we need to have high availability of our app or our website, for example. Obviously, you would not like a user to visit your website and all of a sudden your website crashes. And one of the common reasons for website crashes is, for instance, there are a number of users or thousands or millions of hits coming to your websites and your actual site or app is not scalable, right? So we'll take a look at how to monitor, and before I discuss the tools, here we're just talking about the rules for application performance and availability. Similarly, automated scale up and down or in and out, so that's part of your rules, should be built into your DevOps environment. And we also monitor these applications to drive insights into backlog from production. So it gives us a trail or a history and metrics, if you will, so that we can understand our development environment better from the production perspective. So it's a very important tool that we need to use and must have for the DevOps environment. Here are the tools. So the APM tools simply allow us to target bottlenecks within our applications framework. And one of the leaders in these tools is New Relic. So as a homework and as a task, you need to go out there, search New Relic, and then post into the discussion area what you find. What does this tool do? What are the strengths of this tool? What are the weaknesses of this tool? And so on. But right now, it's a reigning market leader, which lets you pinpoint precisely where and when bottlenecks are occurring. Similarly, the second tool is App Dynamics. It's also a great tool, enabling you to monitor Java, .NET, PHP-based, or Node.js-based applications. And the third tool that I picked up is the CompuWare APM and Boundary. This is an enterprise-geared APM tools which give you a clear view of the user experience, offering metrics like data transactions, even down to the very core fundamentals. So you'll get metrics like data transactions, performance, and user requests. So depending upon the app, the size of the app, and the number of users that are going to be accessing the software, you can implement any one of these APM tools. So as a practice, once again, take a look at these tools, find out more information about App Dynamics, CompuWare APM and Boundary, for example, or New Relic, and then let's have a discussion in the discussion area. I'd like to get your feedback as to which tool you would prefer if you were to manage the DevOps environment. So next, I'm going to highlight the various types of monitoring that we can do. So within the application monitoring or the APM tools, first, the hypotheses-driven development requires telemetry. And we need to have a proactive approach and not a reactive action. So every time you are setting up a DevOps environment, make sure that you are actually taking a proactive approach. And one of the best examples that I can give as a practical experience is that before you develop a software or app, right, or before the first piece of code is written, make sure you have your QA environment, your production environment, your operations environment, all environments are established. So before jumping into development, right, do not just jump into development and then later try to assemble a team of QA or the ops team and whatnot. So be proactive, not reactive. The types of monitoring are usage, availability, performance, and then custom telemetry as well. So this is in essence the application monitoring, and it also covers areas like end user experience, the UI, the server itself, the hardware itself, that is behind the scenes, the DB or the database monitoring, the service level management, performance troubleshooting. All of these are part of the application monitoring as well. And the tools that we talked about earlier, they would help you identify areas, bottlenecks, and then also generate lots of reports so you can actually see which areas need your attention. So hope this helps. Practice, and let's move to the next lesson. So we're at the course conclusion of our DevOps Fundamentals course. Let's take a look at what we actually covered. Just a quick recap so that we understand what were some of the important areas that were highlighted throughout this course. So what did we learn? We started off by understanding and taking a look at what DevOps is. We dived into the value of DevOps, why is it necessary, and I also demonstrated some of the salary or the employment or the typical value in dollars that DevOps engineers make, whether you're starting off or you're an experienced DevOps engineer or developer. So either way, I demonstrated the salary report as well. So you get an idea, if you're wishing to make this your career, you'd have a better understanding. I also talked about Agile and Scrum methodologies and framework in terms of software development and app, so that we understand the entire development process. How does it work? We also took a look at different demos, right? Different tutorials, in fact, hands-on experience. working with Kubernetes, Google Cloud, creating virtual machines, and then clusters. Then we get into the concept of Git, which is simply version and source control, which is important. So I demonstrated how to access Git using the internet, for example. You can download Git software and take a look at it, play with it. And of course, I assigned lots and lots of homework and practice tasks regarding this particular area. Continuous integration and continuous delivery. One of the two important aspects of DevOps. We discussed and highlighted and explained the concepts and also the tools. For example, I talked about a tool called Jenkins, and you can take a look at, you can Google the word and find out what that is. It's simply a continuous integration tool that is very popular within the DevOps arena, and we use it almost on a regular basis to take a look at the continuous integration aspect of the development process. We also talked about configuration and release management of our software and app, and of course I highlighted and explained what to look for, what are some of the tools and best practices as well. And finally, the application performance monitoring. We talked about tools such as Boundary and so on. Relic is very popular, which allow you to actually monitor the performance of not only your application, but it also involves hardware and other areas that you can monitor just to make sure you have a quality product at the end. So the overall objective of this course was to give you a solid understanding and flavor of the DevOps area and what goes into DevOps. So it's development and operations under one roof, but I also added teams like quality assurance, which is known as the testing team, right? They test the framework, test the code, test the software, and also other teams, cross-functional teams, if you're working from within the same environment or your teams are spread across globally. So I highlighted platforms such as Google Cloud, Amazon, Kubernetes, Jenkins, Docker is very important. So we took a look at all of that. So I hope this gave you a solid understanding of what DevOps is all about before you actually decide to move into this area. Very fast growing area, exponential growth that we're experiencing in this area. I encourage all of the new developers or even experienced developers to actually start and dive into the ops environment and actually do a DevOps framework, because this is essentially the future. As more and more enterprise level organizations are moving towards the cloud, DevOps is inevitable. Okay, so with this, I'd like to thank you for taking this course and going through the concepts. Practice, take a look at some of these concepts. Feel free to reach out to me or in the discussion area. I'd be more than happy to help. I'd like to thank you once again, and I will see you in my next course.